Hi students, next one important topic about lines, angle between two lines. Consider the two lines, R vector which is equal to A vector plus S into U vector, R vector which is equal to B vector plus T into V vector. So these are the two vectors, two lines in vector notation format. Drawing any two lines here, we want to make an angle, isn't it? So two lines want to be intersect, right? Draw a line here and one more line here. This is R vector which is equal to A vector plus S into U vector, and this one is R vector which is equal to B vector plus T into V vector. Just to think about that, this is a line. This line has a parallel vector, isn't it? What is the parallel vector? U. You may draw here parallel to this line. This is nothing but U vector. And this opposite line, it has a parallel vector. We know that this is the parallel vector B, nothing but the V vector. So draw this V vector here, so parallel to this one. So this is parallel to this one, so V vector. These two vectors are definitely will be intersect. The line also will be intersect, and this vectors also will be intersect. Now we want to find out the angle between two lines. Okay, so the line should be, there is no end, isn't it? So it will be intersect wherever, we don't know the exact point, but the angle of inclination for these two lines is equal to the angle of inclination of these two vectors. Okay, because of these two lines are parallel, isn't it? So parallel means it is easy to find out the angle between two lines is equal to angle between these two parallel vectors. Okay, angle between these two parallel vectors. What are the two parallel vectors? U vector here and V vector here. So we can derive the formula. The angle between two lines is, you want to use the formula as cos theta. Okay, cos theta is equal to U vector dot V vector divided by magnitude of E vector into magnitude of V vector put modulus, because the theta should not be in negative format, right? Then theta will come, theta is equal to cos inverse of modulus of U vector dot V vector divided by magnitude of E vector into magnitude of V vector. Okay, this is the form for angle between two lines. We can't find out directly. So angle between two lines is corresponding to equal to angle between these two parallel vectors. Okay, thank you. Hi students, this is example 24. A straight line passes through the points 1, 2, minus 3 and parallel to the vector 4a vector plus 5j vector minus 7k vector. Now we want to find out the vector equation. Parametric form, non-parametric form, as well as the Cartesian form, right? So now look at the question here. A point and a parallel vector is given. Parallel vector is given. So this is the theorem 11. Okay, theorem 11. So we can write directly. Let A vector with the position, the point position vector is A vector is equal to, we want to write in vector format. First point 1, so I vector. Second point plus 2, so 2j vector. Third point is minus v, not right, minus vk vector. And take the parallel vector b, u. We can take the b, whatever it is. So I choose u. Okay, u vector is equal to 4a vector plus 5j vector minus 7j vector. 4a vector plus 5j vector minus 7j vector. I know the equation, okay? So now parametric form. Parametric form of equation, right? We know the formula R vector which is equal to A vector plus some scalar. We can write as S into what? U vector. Now R vector which is equal to this A vector here, I vector plus 2j vector minus 3k vector plus S into 4a vector plus 5j vector minus 7k vector. You will write as it is. This is nothing but the form of what? Parametric form, right? Parametric equation of straight. Now we have to move on non-parametric form, right? Next one, non-parametric form. What is a non-parametric form? the equation be r vector minus a vector cross b vector, which is equal to what? 0. This is nothing but non-parametric form, right? So now just you want to apply the value here. R vector minus, what is a vector here? I vector plus 2j vector minus what? 3j vector cross b vector is nothing but 4i vector plus 5j vector minus 7j vector equal to 0 vector. This is nothing but non-parametric form of vector equations, right? Next one, Cartesian form. Third one, Cartesian form. What is a Cartesian form? Form it x minus x1 divided by y minus y1 divided by z minus z1 divided by n. So this is a Cartesian form of a line. Now we have to fix the point B, x1, y1, z1, be the points, given point, 1, 2, minus 3. And the vector L, M, N. This is the parallel vector coefficients ijk. What are the parallel vector? 4, 5 and minus 7. So to put the ratio, right? 4, 5, and minus 7. Now this is the element. Just see what apply here. X minus x1 value 1, okay, 1 divided by 4. Which is equal to y minus 2 divided by 5. Here, z minus 3 divided by minus 7. Here, minus 7 minus 3, what will come? Plus. Okay, so x minus 1 divided by 4, y minus 2 divided by 5, which is equal to z plus 3 divided by minus 7. So, this is required equation, Cartesian equation of the line. Okay, thank you. Hi students, this is example 25. The vector equation in parametric form of a line is, the vector equation they are given in parametric form already. Okay, this is the parametric form of the equation of a line. Now they are asking find direction cosines, DC, I wrote DC structure. Okay, DC means direct cosines. And a non-parametric form and the Cartesian form will be the easiest one. Now, what is mean by direction cosines? Okay, just to draw the coordinate axis here, I will explain what is the direction cosine. So x, y, z, and you see, it is a line. A line acts a parallel vector too. So it should be a parallel vector like this. Now, the lines makes an angle with the coordinate axis. We want to consider this is alpha. We want to take the cosine cos alpha, cosine value, right? Cos alpha. And cos beta, then the same way here cos gamma. So the vector makes an angle with the coordinate axis, namely alpha, beta and gamma. Then the value of cosine, we are assigned the cosine value cos alpha, cos beta, cos gamma. This is nothing but direction cosines. This is nothing but direction cosines. Okay, now we want to find out direction cosines of a given vector, right? Imagine this is a u vector. U vector is equal to a vector plus 3j vector plus 5k vector. So these are vector. Now we want to find out the direction cosines. With direction cosines before, we want to find out direction ratio. Direction ratio is nothing but the component value of the coefficients of ijk. This is nothing but 2, 3, 5. This is nothing but direction ratios. Now direction cosines means you want to imagine that this is a vector from a vector and you want to find the magnitude value here. So 4 plus 9 plus 25 and take the square root of this one. So we get 25 plus 9, 34 plus 4, 38, root 38. Now the direction cosine is nothing but 2 divided by root 38, 3 divided by root 38, 5 divided by root 38. So these are the direction cosines. So direction ratios means you want to take the parallel vector first. Okay, parallel vector, take the components of ijk and take the magnitude value. The components only you are finding direction ratios, right? You want to find out direction cosines means take magnitude value divided by each component, we get direction cosines. The concept want to be applied here only. Okay, right. Now see the question. Now the example 6.25, I wrote here solution. Given equation is r vector which is equal to 3a vector minus 2j vector plus 6k vector plus t some scalar 2a vector minus j vector plus 3k vector. Here a vector which is equal to 3 vector minus 2j vector plus 6k vector. This should be a point, isn't it? And this one I noted, this one is a u. U is nothing but 2a vector minus j vector plus 3k vector. This is nothing but what? Parallel vector. Now we want to write direction ratios, right? What is the direction ratios? Direction ratios, you want to pick out the coefficients of ijk, 2, minus 1 and 3. Next, we have to find the magnitude value of this one, u vector. So we have to take the square value here. 2 square nothing but 4, minus 1 the whole square nothing but 1, and 3 square nothing but 9. So it will be root 14. Therefore, now we have to apply the direction cosines. So direction cosines nothing but 2 divided by root 14 minus 1 divided by root 14 and 3 divided by root 14. So in parallel vector we want to pick out the component of ijk 2 minus and 3, that is nothing but direction ratios. Here you are using u vector this one, you want to find out the magnitude of u vector, then divide by each term you get direction cosines. Okay, so first question mark. Next one. Next one, non-parametric form. Non-parametric form. Non-parametric form means we want to omit the scalar. We want to omit the scalar. Just to see, and then bring this side r vector minus inside the bracket of write 3 vector minus 2j vector plus 6k vector, and then put cross. Then take this vector 2a vector minus j vector plus 3k vector which is equal to 0 vector. Because non-parametric form is r vector minus a vector cross u vector which is equal to 0 vector. R vector minus a vector cross u vector which is equal to 0 vector. So that's why I think this is a vector and this is u vector. I wrote already, so no need to write again. So r vector minus a vector, this one cross u vector, this one. So this is nothing but non-parametric form of given equation, right? Next one, Cartesian form. Cartesian form, we have to pick up the x1, l1, sorry, x1, y1, z1, and mn first. x1, y1, z will be point here, so pick up the components 3, minus 2, and 6. L, m, n be the dash ratios, that means parallel vectors. We have to choose a component here. 2, minus 1, 3. Now, Cartesian form, you know, so put it in here. Cartesian form, x minus x1 divided by m, y minus y1 divided by m, z minus z1 divided by m. Just to apply the value here, substitute value here, x1, l1, okay? And m. X minus 3 divided by, what is the value of l? 2. Y minus of minus 2, it will be plus. Y plus 2 divided by minus 1. And z minus 6 divided by the value will be here, 3. So x minus 3 by 2 equal to y plus 2 divided by minus 1 equal to z minus 6 divided by 3. This is the Cartesian form of given line. Okay, thank you. Hi students, this is example 26. Find the vector equation and the vector equation in parametric form and the Cartesian equation of the line passing through the points minus 4, 2, minus 3 and is parallel to the line, right? So passing through the point is we have to take as a vector, and this one we want to assume we want to take u vector. So imagine the general form of Cartesian is x minus x1 divided by l, which is equal to y minus y1 divided by m, which is equal to z minus z1 divided by m. This is general form of the Cartesian equation of the line. Just look here. The coefficients of x, y, z are 1 to b plus 1. You see, here minus symbol is there. Here 2z is there. So this is not in the form of general. Okay. So you want to make is in the general form. How to make? So very simple, right? So now you want to multiply, right? Given point. Okay. First solution. Given point. Given point is nothing but minus 4 comma 2 comma minus 3, and the given line, given parallel line, not okay, given parallel line is minus x minus 2 divided by 4, which is equal to y plus 3 divided by minus 2, and 2 is at minus 6 divided by 3, which is not in standard form. So if you want to make as a standard form, then multiply by minus 1 both numerator as well as denominator. It will be here what x plus 2 divided by minus 4, which is equal to y plus 3 divided by minus 2. And take 2 common outside here. 2 is at minus 6. Take 2 means z minus 3 divided by 3. Bring the 2 here, it will be 3 by 2. Okay? It will be 3 by 2. Right. Now, by given data, we can assume a vector which is equal to this one minus 4i vector plus 2j vector minus 3k vector, and u vector which is equal to the denominators we want to take. So here x1, y1, z1 are points, l, m, and are parallel vectors, right? So denominator only want to take. So minus 4i vector minus 2j vector plus what? 3 by 2 into k vector. Now we have to find out the equation of what? Line. Okay? In parametric form as well as Cartesian form, right? Now we see. So these are the given data. The first one is parametric form. Parametric form, the equation is r vector is equal to a vector plus s into u vector. R vector is equal, what is a vector here? Minus 4a vector plus 2j vector minus 3k vector plus s into b vector, this one minus 4a vector minus 2j vector plus 3 by 2 into k vector. This is what? Parametric form. Next one, Cartesian form. So Cartesian form, we have to take x1, y1, z1, x1, y1, z1, which is a point here, minus 4, 2, minus 3, and l, m, n, that must be here, minus 4, minus 2, 3 by 2, minus 4, minus 2, 3 by 2. Right? Now we have to apply the general equations, okay? Which is x minus x1 divided by n, y minus y1 divided by n, z minus z1 divided by n. So minus 4 means plus 4. So x plus 4 divided by minus 4. Here y minus 2 divided by m. What is the value of m? Minus 2. Here z minus of minus means plus 3 divided by 3 by 2. Otherwise, we can arrange like this. X plus 4 divided by minus 4, y minus 2 divided by minus 2, which is equal to, they can go there, 2 is a plus 6 divided by 3. Okay, this is the required Cartesian form of equation. Okay, thank you.